Today we're going to be measuring segments. So let's first look at the ruler postulate. Points of a line can be put into 1-to-1 correspondence with real numbers so that the distance between any 2 points is the absolute value of the difference of corresponding points. We're going to be looking more at that more specifically when we get to our examples. Congruent segments are 2 segments with the same length. Let's first take a look at our first example. We want to find the length of FG. So from F to G, we have a distance of 1, 2, 3, 4. So FG equals 4. We want to look at G to J. So 1, 2, 3, 4, 5, 6. HJ. So if H we start at 1 and we're going to J, that means we're going up a length of 5. GI. Start at G and we're going up to I, so 0 to 3 means we have a length of 3. And IJ. I we're starting at 3 and we're going up to 6, so the difference between 6 and 3 is 3. So are any of these segments congruent? Yes. GI and IJ are congruent because they have the same length. Segment addition postulate. First let's draw a picture. If we have segment AC, and we have a point B in between. So if 3 points, A, B, and C, are collinear, which are they lying on the same line, and B is between A and C, then AB plus BC equals AC. So what we're saying is the distance from A to B plus the distance from B to C equals the whole distance. So let's take a look at this example. I want to know the distance from A to C, that length. Well, if AB is 19 and BC is 3, AC is 22. Let's look at another example for that problem. We have that EG, so our whole distance is 60. EF, this segment is 2x minus 8, and FG is 3x minus 12. So based on our segment addition postulate, we know that our 2 small segments need to be added together to equal our whole distance. So let's combine like terms. 2x and 3x is 5x. Negative 8 and a negative 12 is a negative 20. So now if we add 20 to both sides, 5x equals 80. And when we divide by 5 to both sides, x equals 16. So we want to know the length of EF and FG. So we want to find the length of EF. We know EF is 2 times x minus 8. But we know x is 16, so we can plug it in. So 2 times 16 is 32. And when we subtract 8, we know that the length of EF is 24. So let's look at FG. FG equals 3x minus 12, but we solved to find that x is 16. So 3 times 16 is 48. and we minus 12, we get 36. So if we take a look, EF is 24 and FG is 36. If we add 24 plus 36, will equal 60. Midpoint. Midpoint is a point that divides a segment into two congruent segments. So let's take a look at our example number 4. If Q is the midpoint, that means these two are equal segments. So that means that 2x plus 1 equals 3x minus 4. So if I subtract 2x to both sides, we're left with 1 equals 1x minus 4. I could add 4, x equals 5. So to find, we want to find what the length of PQ, QR, and PR. So 2 times 5 plus 1 is 10 plus 1, so PQ equals 11. 3 times 5 minus 4, 15 minus 4. So QR equals 11. So we know we solved that right because those are the same. So that means the whole length, PR, equals 22. And our last example for the day. We have that M is the midpoint of AB. So if we have A, B, M is the midpoint. So that means those two are equal segments. AM is 24, and MB is 4x minus 12. We want to find the length of MB. So we know that these two are congruent, so 24 equals 4x minus 12. So if I add 12 to both sides, 36 equals 4x. So x is going to equal 9. So to find the length of MB, take 4 times 9 minus 12. 36 minus 12 is 24. Which we know we solved that correctly since AM is 24, so MB